skip through that.
I did the problem.
Okay. So some definitions before we go into things. Let's talk about an ordered pair. So an ordered pair is just a point, x comma y. A relation is a set of ordered pairs. Of real numbers. So if I have the set with the coordinates 1, 2, 4, -7, a half or a third, comma, a half, that's a relation. It's just a set of ordered pairs. You all tell me, what's domain? Matt knows. Yeah, the domain are the x values. If domain are the x values, guess what range is? Y values. All right, function. A relation in which each ordered pair has a different domain. What does that mean when I say each ordered pair has a different domain? What is not allowed to be repeated?
X values.
Good. Do not repeat x values. Okay, so for our first problem, I just want us to list out, I'm going to give you a relation. So let's say I have the relation with the set of points 2, 0, 7, 1, 3, 1, -2, 5. I want us to list the domain. I want us to list the range. And I want to know, is this relation a function? Okay, so what I'm giving you is a set of points. It's a relation. It's not a graph, right? I'm not giving you a graph of something. I'm just giving you a set of points. Because I'm just giving you a set of points, the domain is going to be all the x coordinates in the set of points. So what is my domain? 2, 7, 3, -2. The order does not matter. Okay, because the problem I gave you was originally a relation, it's not a graph. Our range, again, is just going to come from the y coordinates in our set of points. So we're 0, 1. Do I have to put 1 again? No, it's already there. I don't have to put it down again. And 5. All right, now I'm asking you, is this relation a function? So we're going to look, right? We are not, for it to be a function, what are we not allowed to repeat? The x. We're not allowed to repeat the domain. Are we allowed to repeat the range? Yes. So I'm looking, 2, 7, 3, -2. Have any of the x coordinates been repeated? No. So is this a function? Yes. I actually really like you, Dylan. I do. Okay, so think of a graph and think of, you guys don't have to draw this. We said a function is when none of the x-coordinates are repeated. What happens when an x-coordinate's repeated? For example, if I have 2, 0, and then I have 2, 2. All right, so 2 zeros here, and then 2 2's here. What happens when an x-coordinate's repeated? You get a vertical line. So when an x-coordinate's repeated, we get a vertical line. So how can we tell if a function, how can we tell if a graph is a function without looking at all its coordinates? There's something called the vertical line test. All right, so let's write out the vertical line test. All right, so if the vertical line intersects the graph at more than one point, not a function. So is the relation a function? But this time I'm going to give you the relation as graphs. All right, so how do we know if it's a function? I'm going to go and I'm going to see if any of the x-coordinates are being repeated. So I perform the vertical line test. And what do we realize over and over and over again? It continues to fail this vertical line test because the vertical lines are touching the graph in more than one place, which means the x-coordinates are being repeated. So is this a function? Oops. Is this a function? No, not a function. It is a circle. That's true.
You can assume you can assume it's on the graph. I can you can assume. You can't assume.
Okay, so what about this linear equation? Is this linear equation a function? Well, let's see. I'm drawing my vertical lines. In these vertical lines, am I intersecting the graph at more than one spot? No, so is it a function? Yes. All right, so now this isn't a graph. This is a set of x-coordinates and a set of y-coordinates. These are the x-coordinates 1, 2, 3, 4. And the y-coordinates are 1, 4, 9, 16. So see how I'm drawing lines connecting the x-coordinates to the y-coordinates? That means it's 1, 1, 2, 4, 3, 9, 4, 16. That's the x-coordinate going to the corresponding y-coordinate. The arrow's telling you which corresponding y-coordinate it's going to. So here, if you wanted to list out your set of points, you can, but you don't have to. This would be 1, 1, 2, 4, 3, 9, 4, 16. Are we repeating any x-coordinates? No, so is this a function? Yes. All right, what about this next one? Again, here are the x-coordinates, here are the y-coordinates. So here I have 1 going to 2, but I also have 1 going to 3, and then 4 is going to 5. All right, can you list out the coordinates if you want? Sure, but what should you realize just from how I set this up? I have 1, the x coordinate going to 2, and I also have that 1 going to 3. What does that mean? That 1 has been repeated. So is this a function? No, it would fail the vertical line test because that x coordinate's repeated. So no, this is not a function. All right, one more. Dylan, focus. This is why you're always like a minute behind. Okay, so in this scenario, are any x coordinates being repeated? What is being repeated? The y coordinates being repeated. Is that okay? It is absolutely okay. This is still a function. I still remember when I was in high school and my teacher said to us, it's the idea of people and birthdays. Every single person can only have 1 date of birth, right? I can't be born on multiple days. So I could only have 1 date of birth, but multiple people can have the same birthday. That's the idea of function versus not a function, okay? Every single person can only have 1 date of birth, but multiple people can share that date of birth. That means like we can have multiple Ys, X is going to that Y, so like me and Navia, we have the same birthday. We're 2 different people both being born on the same day. That's okay. But what we can't have is Miss Abdelbar was born on the 2nd and then she was born on the 3rd. Can't happen. All right, so now we're going to get a little bit more into things. So I want us to determine the domain range and if the relation is a function. Okay, I set it up, I'll let you catch up. We ready, Dylan? Okay, so for the domain, what we want to do, remember domain is the x values. So we go from smallest to biggest. In a graph, isn't the horizontal axis our x-axis? And if we're going from small to big, I have to go from left to right. So what I'm looking at is the furthest point to the left. What's the furthest point to the left? It looks like an arrow, right? And then I'm going all the way to the right. What's my furthest point on the right? Doesn't it look like another arrow? Right, so what does the arrow mean? It's going left forever, it's going right forever. What's to the left forever? Negative infinity. What's to the right forever? Positive infinity. There's 2 ways to write this. We can write this in set notation. So squiggly brackets, x such that negative infinity is less than x, which is less than positive infinity. Or, what's the other way? Yes. So we can go, is infinity ever included? No. So we can say parenthesis, negative infinity, comma, infinity, close your parenthesis. Just depends what you prefer.
Yeah, we did.
So we did do this in the beginning of the year. So remember, just the top is set notation. The bottom is interval notation, in case you forgot the names. Okay, yes.
Is there any specific way you want us to like write on?
I might ask for both ways. So I might ask some to write in set notation, some to write in interval notation. I really don't remember, but we should know both. Okay, range. So now the range, what are we looking at? So the range is the y. Don't we know that the vertical line represents the y-axis? So we're again going from the lowest point to the highest point. So looking at my graph, my lowest point is where? 0. Is 0 included? Yes. How would I know if 0 was not included? It would have to be what kind of point? An open circle. If 0 were not included, it would be an open circle. It is a closed circle. And then I'm looking at my highest point. Well, what's my highest point? Arrows, which are infinity. Exactly. So set notation. This time it's not x. This time it's what? Y, such that now my lowest point is 0, is less than or equal to, because it's included, right? Less than or equal to y, which is less than, we can never be equal to infinity, which is less than infinity. And if I were to write this in interval notation, anybody remember how to write this in interval notation? Matt? You got it. Because 0 is included, that is our square bracket. So my last question, is this a function? So I'm going to perform my vertical line test. Am I ever going to hit this in more than one place? No. So is it a function? Yes, it is a function. Okay, same directions. Determine the domain and range and if the relation is a function. Actually, I want that to be an open circle. Oops.
Oh, an open circle.
Yep, sorry, open circle.
It's like a number line. That's a number circle.
It's a parabola.
Supposed to be a parabola. I'm not very good at this. Whatever. Okay, so domain. What do we look for our domain? Where do we look? From left to right. So my furthest point left is, and then I'm going all the way to right. My furthest point is positive 3. So we're looking on the x-axis. So we go from negative 3 to positive 3. Are they included? No, because they're open circles. So if I'm writing this in set notation, we're going to say x such that negative 3 is less than x, which is less than 3. I didn't put the equal sign, less than or equal to, because they're open circles. How would I write this in interval notation? Anybody know? How would I write this in interval notation? Aditya.
Is it bracket, negative 3, comma?
Why bracket?
Because negative 3 is not included.
So that should be parenthesis. Bracket is the square one. That should be included. So it's a parenthesis when it's not included. So we're going to say parenthesis, -3, comma, and then what, Aditya? 3, and then how are we closing this off?
Another one of the
Parenthesis, you got it. Now let's talk about range. All right, so what are we doing for range? Bottom to top. All right, my lowest point is 0. My lowest point is 0. So why such that? Is 0 included? Absolutely. If it's just part of the curve, meaning no open circle is shown, it is absolutely included. So we're going to say 0 is less than or equal to y, which is less than, what's my highest point? 3. Is 3 included? No. Because remember, it's open circles at 3. All right, so how would I write this in interval notation? How would I write this in interval notation? Somebody else.
Would it be like the
Square bracket?
0, 3 parentheses?
You got it. Zeros included.
No, but if it goes through 0, it's always inclusive.
Do you not listen to what she says? No, he does.
Aw, thank you. Okay, so that's the end of that. Let's talk about values and composition of functions. This is where we can get tedious with things. Values and composition of functions. All right, so for any ordered pair, x comma y of a function, we have f of x equals y. So I'm going to first say how to read this. F of x equals y. And what does this mean? F of x equals y. It means the value of our function f, so the value of f, which is our function, at x is y. F of x equals y. What does that mean? If I insert the x coordinate into whatever equation goes with the function, then I can figure out the corresponding y coordinate. Right, the other way of looking at this is the function at the domain is the range. So let's start off simple. Let's say I give you a relation that's just a set of ordered pairs. So 1, 0, 2, -1, 7, 3. And I ask you to find f of 1. Okay, what is this asking, f of 1? They're asking, in my function or in my relation, when my x coordinate is 1, what is the corresponding y coordinate? So in my relation, when my x coordinate is 1, what's my corresponding y coordinate? 0. So f of 1 equals 0. All right, what about f of 7? What is f of 7? Not this side of the room, this side of the room. What's f of 7? 3. So this is saying, in my relation, when my x coordinate is 7, what is my corresponding y coordinate? It is 3. All right, let's step it up just a bit. All right, so now I'm going to say if f of x is equal to 2x plus 1. We all know f of x is interchangeable with y, right? Do we all realize this is the same as saying y equals 2x plus 1? All right, just so you know. I want us first to find f of 1. Right. In order to find f of 1, now I didn't just give you a set of ordered pairs where I can say, okay, when x is 1, what's the corresponding y value? But what I can do is go and plug it into my function, and when I plug into my function and simplify down, won't that give me the corresponding y value? What's going on? Chris, you never participate. Okay. Now you all stopped? I'm a little freaked out. All right.
I think I know the answer.
Okay, what's our answer?
3.
Funny. Okay, so here we're going to have 2 times 1 plus 1. So we're going to have 2 plus 1 is 3. So what does this tell us? When x is 1, y is 3. So let's just do this. When x equals 1, y equals 3. That's what this tells us. All right, next one. Same function, 2x plus 1, but now I'm going to ask you to find f of a plus 1. So what am I going to do? Anytime I see x, what am I substituting in? A plus 1. So this is going to be 2 times the quantity of a plus 1, I need it in parentheses, plus 1. Distribute in that 2. So we have 2a plus 2 plus 1, which is going to be 2a plus 3. So this is saying when x is a plus 1, y is 2a plus 3. All right, so now what do I want us to do? I want us to find f of a plus h minus f of a. So what am I doing? I'm first going to substitute a plus h, then I'm going to substitute a, and then subtract those. So we are going to have 2 times the quantity of a plus h plus 1 minus 2 times a plus 1. And I'm going to put this in brackets. Why am I putting that in brackets?
Because the negative gets applied to both.
Good, because the negative has to get applied to the whole function, right? Not just the 2a. So let's distribute this in. We're going to have 2a plus 2h plus 1. That 1 is not part of the parentheses, so the 2 does not get distributed to it. And then I have minus, I'm going to keep it in my brackets for now, 2a plus 1. So now I'm going to distribute in that negative. So I'm going to have 2a plus 2h plus 1 minus 2a minus 1. What happens here? The 2a's cancel and the 1's cancel. So what am I left with? Just 2h. All right, we're going to step it up a little bit more. Are we ready? Okay, so now we're going to talk about composite functions when we combine different functions together. So let's say I told you f of x equals x plus 2, but then I also told you g of x equals 3x. We're going to start off simple. I want you guys to do this one on your own. I want you to find f of 2 on your own. All right, what is f of 2? 4. 4. Anybody need to see me do it? All right, so now we're going to talk about the composite functions, mixing in more than one function together. So let's say I have, for letter B, f of g of 2. These are actually a little fun to me, I'm not going to lie. So what do? We go from the innermost parenthesis out. So in my innermost parenthesis, what do I have? G of 2. So I'm going to go to g of x. And what am I going to do with g of x? I'm going to substitute in a 2. So now I'm going to have f of, so we're working here, 3 times 2. Everybody okay with how I got the 3 times 2? What is 3 times 2? 6. So now I'm left with f of 6. What do I do now? Now I'm going to go to the f of x function. And anytime I see x, what am I going to do? Plug in a 6. So this is going to be 6 plus 2, which is 8. So f of g of 2 is 8. All right, next one. So now I'm going to have f of g of x. Okay, so now this is saying f of, there's no number for that I'm substituting in the g of x function. So they're saying, okay, well, f of g of x. Well, what's g of x equal to? 3x. So now I'm going to have, instead of g of x, I'm going to have 3x. Now what is it saying? F of 3x. So now I'm going to the f of x function, and wherever I see x, what am I substituting in? 3x. So this ends up becoming 3x plus 2, which is just 3x plus 2. I want you guys to try this next one on your own. 1, 2, 3 more problems. Guys, I haven't been here for 2 days. I'm not really feeling the love. And you drop tomorrow. Oh, tomorrow's not. So we drop on Monday. Look at that. All right, go. G of f of x. You want me to go back up? You didn't write it down?
I'm on my 6th page.
Very cool. That means you're right there, okay?
No,
There's no
I
reason
take the
to be on
notes you read.
fire.
I take the notes.
I mean, you have a baby notebook.
Yeah, baby no.
It is a baby notebook.
Rule number 1, you don't use a composition notebook
For
in
math.
math.
That's for
That's
English.
not how it works.
And it's only if the English teacher makes it. Otherwise, you burn them.
I'm in agreement with that. Composition notebooks are the worst.
Yeah, exactly.
You need the fat spiral notebook.
You need to actually.
You need the college ruled like 5-star.
Yeah, like this.
Wide rule is garbage. That also needs to be burned.
Yeah, I'm not a fan of wide ruled.
Disgusting.
Yeah, too wide.
I'm glad we're in agreement.
It makes me.
Who's got this? Who's got this for me? Left side of the room. Anybody? Anybody at all? Simon?
3x plus 6.
It is 3x plus 6. Anybody want to see me do it? No? We're good? We all got that? Okay, so we ready to step it up a bit? Sure, why not? So let's say I tell you f of x is equal to 2x minus 3, and g of x is equal to x squared minus 2. All right, starting off simple, I want you to do this first one. I want you to find g of negative 1 minus f of negative 2. You all do that one on your own, and then I'll step it up for you. David, when I smile, you smile back. That's how it works when somebody's nice. All right, what'd we get? Aditya?
I didn't do it yet.
Claire? 6. I got 6 also. Who needs to see me do this? Anybody? Don't be shy. All right. So now we're going to step it up a lot. So now I'm going to have g of c plus h minus g of c all over h. Not g of h or f of h, just over h. Okay. So we're going to have to simplify this. Oh, side note. You can perform all operations with functions. Okay, so the first thing we're going to do of g of c plus h. So I'm going to where it's g of x, and wherever I see an x, what am I substituting in? C plus h. So this is going to be c plus h squared minus 2. Then we have minus g of c. So now minus, and now wherever I see an x, I'm now plugging in a c. So in my brackets or parentheses, whatever you want to use, I'm going to have c squared minus 2 all over h. Did I lose anybody with that numerator? Who? Dylan? Okay, did you understand the first part with the c plus h squared minus 2? Okay, so now it's saying minus g of c. So you're going back to g of x, but instead of anytime you see an x, what are you substituting in? A c, so then it's c squared minus 2. I had to put the brackets because this is bigger than a monomial, so I have to distribute in that negative. All right, let's keep going now. Let's simplify down. So now I'm going to have c plus h squared minus 2. I have to actually FOIL this out. I have to FOIL this out. When I go and FOIL this out, I'm going to end up getting c squared plus 2ch plus h squared. Now I'm going to distribute in that negative, so minus c squared plus 2 all over h. And now I'm going to go simplify that numerator. Oh, did I forget my minus 2? Are you guys okay if I just put it at the end? It's okay? Okay. So now what am I going to do? I'm simplifying that numerator. The positive 2 and the negative 2 cancel. The c squared and the negative c squared cancel. So now I'm left with 2ch plus h squared over h. I am not done. Why? I can pull out an h. When I pull out an h, I'm going to get 2c plus h over h, and then the h's cancel. And we just end up with 2c plus h. Are we ready for our last problem? Oh, that when we FOILed this out, we got that, but then it should have been a minus 2 and then minus c, so I was low on room, so I just put it there. That better? Yes, we're ready? guys, I have a whole nother page.
Oh.
Wait, what?
Sorry.
Wait.
That's not
We can do it like extra.
good
Yeah.
tomorrow.
No. Okay, so what do? We work from our innermost parenthesis out. So I'm going to f of 2. When I have f of 2, I'm substituting that 2 in for x. I'm going to do it in my head. 2 times 2 is 4 plus 1 is 5. So now we have f of 5. Did I lose anybody? Are we good? Dylan?
Yeah, I'm good.
Okay, so now I have f of 5. So now what am I going to do? I'm going to go back to my function, f of x equals 2x plus 1, and now I'm substituting in a 5 for that. 2 times 5 is 10 plus 1 is 11. So now I have f of 11. What do I do now? Go back to our function and substitute in the 11. 2 times 11 is 22 plus 1 is 23. All right, last thing we're doing.
Yeah, I thought this was
I lied. Sometimes I do that.
The last thing we're doing?
Can we have
Okay.
a Claire test for today's lesson?
Yeah,
200 point test. Yeah, that's
Domain
okay.
is the set of all real numbers except those numbers that make the denominator equal to 0. So what does this mean? If I give you a function, your domain will always be all real numbers unless there's a denominator. And then if there's a denominator, what do we have to make sure? That there's no value of x that can make that denominator equal 0. So if I just give you y equals x squared plus 37, do we even need to know what this looks like? No. What is it? What is the domain? All real numbers, all reals. How would I write that in set notation? X such that negative infinity is less than x, which is less than positive infinity. How would I write that in interval notation? Parentheses. We don't even need to sketch that. When's the only time we're worried about the domain? If there is a denominator.
I think we're done.
No, thank you. All right, I'm sorry?
If there's radicals, do we also have to worry about that?
Oh, yeah, we need to worry about radicals also. We do need to worry about radicals. So, yeah, there's 2 scenarios. We need to worry about radicals. We need to worry about denominators. Thank you for that. We will see both of those soon, but not today. All right, let's talk about zeros. The set of all real numbers that make the numerator equal to 0. As long as the 0 does not create a 0 in the denominator. If so, then it is not a 0. I'll let you write that down and then we'll have a chat. Okay, so Remember when we're finding zeros, right? Also called roots. What are we looking for? We're looking for where our graph crosses the x-axis. And where does our graph cross the x-axis? When y equals 0. So when will a function equal 0? A function will equal 0 when the numerator is 0. Doesn't that make sense? The function will equal 0 when the numerator is equal to 0. All right, so let's do a couple of problems. I want us to find domain and zeros of the function. F of x is equal to x squared minus 5x plus 6 over x squared minus 2x. Okay, so what are we going to do? Let's figure out our domain first. Remember, the domain is always all real numbers except for two scenarios: if there's a fraction, if there's a denominator, and also, as Aditya pointed out, if there's a radical. That will change things for us. But for now, we're just dealing with the fraction part, right? So the domain is all real numbers except when this denominator equals 0. Well, when will this denominator equal 0? X squared minus 2x equals 0. I'm going to pull out a GCF of x. So x times x minus 2 equals 0. Is this now factored? Yes. So x cannot equal 0, and what else can x not equal? X cannot equal 2, because that will make the denominator 0. So how are we going to write this? We can write all reals, or you could just put that r, all reals, except, or you know what? You could do all reals, and you don't even have to write except. You could just say x cannot equal 0, 2. So I'll put a little star, set denominator equal to 0. All right, now we'll talk about the range, not the range, we'll talk about the zeros. That was the domain, right? So now the zeros set numerator equal to 0. For the zeros, set numerator equal to 0. So I'm going to take x squared minus 5x plus 6 equals 0. I'm going to now factor this. X minus 3, x minus 2. So what do we end up with? X equals 3 and x equals 2. But what's the problem with x equals 2? When x equals 2, doesn't it make the denominator equal to 0? So can that be a possible 0 for us? No, we have to reject because it makes the denominator 0. So what is our 0? Our 0 is 3, or you can say the point. What's our point? 0 is 3, 0. All right, now we are done. It looks like your homework is all textbook pages.
That's just the point.